All right, good morning, kiddos. This is Miss Banuelos, and I am going to go ahead and teach you guys the lesson for today. Okay, so before we take a look at today's lesson, this here is the handout that you will all need. It looks a little similar to yesterday, what math happened. And then on the right side, it says Giant 1 Simplifying Fraction Puzzles. So thank you, guest teacher, for subbing today's class. If you need to pause the video and you need to pass out the handout for today, go ahead and do that, please. All right, kiddos. Well, before I go into today's lesson, I'm going to go ahead and go back to yesterday's notes. So a quick review of yesterday. Yesterday, we took a look at equivalent fractions and what we noticed how 3/5 and 9/15 are equivalent. So the same amount is shaded, 3 out of 5 pieces, as well as 9 out of 15. But the math that you noticed yesterday, you noticed that to create, so without the diagram, you noticed that to create equivalent fractions, we multiplied, so that's the math, the operation, we multiplied by fractions that had the same number on top, the numerator, and the same number on the bottom, the denominator. And what this creates is a giant 1. So here, any number divided into itself equals 1. And normally we write our regular size 1 like this. But this fraction that has the same numerator and the same denominator creates a nice big giant 1. So our ones were created, our giant ones were created, a big one like this, or we can also write a giant 1 in this form. So yesterday we were introduced to giant 1s, and the math we noticed is that we multiplied by giant 1s to create our equivalent fractions. And we know that they are equivalent because of these diagrams here. The diagrams help us to visually see how they are equal. It's the equal amounts being shaded in, right? So here again, we have 3/5, which is equivalent to 9/15. And we can also say that one of the 5 pieces is equivalent to 3 of the 15 pieces. Okay, so that was a little review of yesterday. So for today, we're going to start off with what math happened. We're going to kind of take a look at what do you notice when we are simplifying fractions, okay? All right, so let's go ahead and with your pencil, you can go ahead and shade a little darker. But what we have here, we have 18/12 and we have 2/3. So these fractions are equivalent, right? So they are equivalent. Go ahead and draw a little line here. Same amount is being shaded. But what we notice here is that this fraction is in its simplest form. So we need, what does that mean in simplest form? So yeah, we have the simplest form means less amount of pieces being cut, but the same amount being shaded, right? So 8/12 versus just simplifying that piece and only chopping it into 3 pieces, but shading 2 of them to make the equal amount, okay? So now let's notice what math happened. So if we look here, we have 8, and 8 we have 2 times 2 times 2. So we kind of like decomposed that 8. We actually broke it down to all prime numbers that make 8. And then let's take a look at the 12. So we have 2 times 2, which is 4, and 4 times 3, which make it 12. So you should notice that the numbers being multiplied to get 8 and our numbers, which are the factors being multiplied to get 12, are all the prime numbers that make up that number. So looking at yesterday, of what we did yesterday, what we notice, when I have a same numerator, the same denominator, that creates what again? That creates a giant 1. Very good. So I notice I have a nice big giant 1 here. And oh, look, we notice another giant 1 because I have the same numerator, the same denominator. So 2 divided by 2 makes a 1. So let's go ahead and create a nice big giant 1. All right. So what I am left with, now that these turned in, not magically, but mathematically, they turned into 1s, my numerator, I have 1 times 2, which gives me 2 for my numerator. And then in my denominator, I have 1 times 3, which gives me 3 in my denominator. So 8/12 simplifies to 2/3. So mathematically, we were able to show that. We were able to do that. Okay, take a look here. Why did this not create a giant 1? So 2 divided by 2, 2 divided by 2, but then I have 2 divided by 3. Yeah, that does not create a 1. It actually creates something less than 1, right? But a giant 1 is only created when we have same numerator, the same denominator, right? Because yesterday we took a look at anytime you have numbers that divide into itself equals 1. Well, this did not divide into itself, which is why 2/3 is not a giant 1. Okay, so now let's take a look at here, the second one. All right, so the second one, I have the fraction 9/15. Let's go ahead and shade that in. We have 9/15. And here it's saying that it is equal to, so it is equivalent to 3/5. All right, so using our diagram, we can see that the same amount is shaded. So those are equivalent. Now let's take a look at the math. What kind of math is done to go from 9/15 to its simplest form of 3/5? And remember, the simplest form, what we notice is that it is the version, this fraction is the version with the least amount or the smallest amount of pieces, right? So let's see the math that we notice. So 9, I have my factors 3 times 3. 15, I have my factors 3 times 5. All right, so then I notice this fraction here, 3 divided by 3. Yeah, that creates a giant 1. And remember, we can write our giant 1 like this, or we can write it like this. Okay, so that created the giant 1. Now, also noticed how my factors are lined up nicely so that I can see my giant 1s. So when we write out the factors for the number, we also want to, maybe, it won't happen all the time, but it is nice when I do have them lined up where I can easily find if my giant 1s, if they are the same from the top and the bottom. All right, so I created my giant 1. So now remember, this is now a 1. So I have, so if you want to put a 1, just to remind you. So now I have 1 times 3, which is 3. 1 times 5, which is 5, right? So what we are noticing is that our giant 1s are used to simplify a fraction. So in our diagram, we can see, oh, I can break it up into less pieces. And if I shade in 3, that's the same amount as if 9 were shaded out of 15. Well, mathematically, we can use our factors to find giant ones to simplify the fraction. So 3/5 is our simplest form. Right there. Okay, so just taking a look at these two problems. We went from 8/12 to 2/3. Yes, they are equivalent, but what we are noticing, the math that happened, is that we are writing out the factors, even prime factorizing our numbers, so that way we can find some giant ones to write its simplest, our fraction in simplest form. Okay, so down here, actually it's up here. So let's fill in the blank. So I have the blank of a fraction. That would be the simplest form. So the simplest form of a fraction is the version with the least or smallest amount of pieces. So notice 2/3 is the version of the least amount of pieces of 8/12. And 3/5 is the version of the least amount of pieces of 9/15. All right, so that is what simplest form is. And down here at the bottom, let's go ahead and write, what did you notice about simplifying fractions? So I noticed we'll give you about a minute or two. What did you notice? Go ahead and answer that. What math did you notice from going from 9/15 to 3/15? Okay, so hopefully that was enough time to write something down, such as, I notice giant ones are used to simplify fractions. I notice that you write out the factors for both the numerator and the denominator. Then you get the giant ones to simplify a fraction. Okay? All right. Now let's go ahead and take a look at the right side. So now that we notice that giant ones are used not only to create equivalent fractions, but also used to simplify fractions, let's take a look at some problems, some puzzle problems where we can see which giant one did I use for each of the problem. Okay, so let me zoom in a bit. All right, so I have the fraction 9/21, and we are going to find out what giant one was used to create the simplest form version, 3/7. What do you guys think? All right, good. Yes, 3/3. So I know 3 times 3 is 9, and 3 times 7 is 21. So the giant one is 3 over 3. Good. And remember, the math that is done, we multiply. So this is a giant 1. If that confuses you, you can also make it a 1. 1 times 3 is 3. And 1 times 7 is 7. So 9/21 is equivalent of 3/7, but it's also written in its simplest form. All right, let's take a look at the next one. All right, so I have 10/16, and it simplifies to something over 8. Let's go ahead and take a look. All right, so my factors for 10, I have 2 times 5. My factors for 16 is 2 times 8. So if we notice, the giant 1 being used is 2 over 2. All right, let's go ahead and finish the math. So I have 1 times 5, which is 5. And I have 1 times 8, which is 8. So 10/16 is equivalent to 5/8, but 5/8 is the version with the least amount of pieces. All right, let's go ahead and why don't you give this one here a try? Let me give you a minute to give that one a try. All right, let's see what you guys did here. All right, the factors of 12. Yeah, some of you might be saying 4 times 3, but let's break down 4 even more. 4 is a composite number. Let's break it down even more. So if I break down 4 more, it's 2 times 2. So that's 4, and then times 3. That would give me the 12. Okay, good. Now let's write out the factors for 20. So I can get 4 times 5. Yep. But let's break down 4 even further. So that way my goal here is to find my giant ones because I want the most simplest version fraction. So the one with the least amount of pieces. So I'll break down 4 even more. 2 times 2 is 4, and then times 5 will give me my 20. All right, now from here, I am going to identify my giant ones. 2 over 2 makes a 1. 2 over 2 makes a 1. Good. So now let's finish the math. So I have 1 times 1 times 3 is 3. And then I have 1 times 1 is 5. So that is 5. All right, so 12/20 is equivalent to 3/5, and 3/5 is written in its simplest form. Now, some of you may think, well, couldn't I just use the 4? So 2 times 2, I could just use the 4, and 2 times 2, I could just use the 4 and found giant ones with the 4. Yeah, you could also do that, and we'll take a look at that some more on Thursday or later this week, right? So 4 would be the greatest common factor. So the greatest common factor could also be used to simplify a fraction. All right, kiddos, let's take a look at one more giant one puzzle. All right, so here we have 2/8, and we need to simplify that. So go ahead and write the factors for 2. What'd you guys get? 1 times 2, that is correct. And now write the factors of 8. We have 2 times 4, but that doesn't fit the puzzle. So maybe we break down 4 to 2 times 2. There it is. All right, let's go ahead and now identify, look for that giant one. Here it is. And now let's multiply. So I have 1 times my giant 1. So 1 times 1 is 1. And then 2 times 1 is 2. Multiply by 2. So 2 times 2 is 4. All right, so 2/8 is the same as 1/4. And 1/4 is the simplest form. Okay. All right, so we looked at, what did we notice going from a fraction to its simplest form? We did some practice with giant 1 puzzles to simplify a fraction. Now on the back side, we're going to practice some prime factorization because that helps us simplifying a fraction. All right, so just a quick reminder on how we do that. So how do we prime factorize? So we have notes in our notebook, but just a quick reminder that to prime factorize, we're going to find any factor pairs. So any factor pairs, and we're going to continue to, break down until we have prime numbers. Okay, so we're going to get any factor pairs, and then we're going to break down to get the prime numbers. All right, so let's take a look at 8. So let's find factor pairs. Any factor pairs? Yep, that works. 2 times 4. All right, 2 is a prime number, so we no longer need to break down. 4 is composite, so we can break that down further to 2 times 2. Prime and prime. Okay, now let's break down 12. Give me any factor pairs. All right, let's use 2 times 6. 2 times 6. So 2's prime. 6 is composite, so let's break that down further. Yep, that's right. 2 times 3. Okay, so I am going to use that. Let me zoom out a bit. I'm going to use those prime numbers to simplify the fraction. If you notice, 8 is the numerator in this fraction, 12 is the denominator in this fraction. So I'm going to use these prime numbers here to simplify my fraction. All right, so let's start with 8. So 8, I have 2 times 2 times 2. My prime numbers for 12, I have 2 times 2 times 3. Okay. Now I'm going to simplify 8/12 by finding my giant ones. 2 divided by 2 is a giant 1. 2 divided by 2 is a giant 1. 2 divided by 3, nope, that is not. All right, now that my giant ones are found, let's go ahead and multiply the numerator and then multiply my denominator. So I have 1 times 2 gives me 2. And then my denominator, 1 times 3 is 3. So check that out. 8/12 is equivalent to 2/3, and we just simplified 8/12 into its most simplest form. Okay, let's go ahead and do that. The next one. So let's prime factorize 21. So give me any factors. Good, that works. 3 times 7. Oh, that was fast. 3 is prime. 7 is prime. So I'm done with factorizing 21. All right, now 28. Good, yep. That works. 4 times 7. Now 7 is prime, but 4, I can continue breaking down to what? Yep, 2 times 2. All right, 2's prime. choose prime. All right, let's go ahead and use our prime numbers to now, let me zoom out. There it is, to simplify this fraction. All right, so the factors we're using for 21 is going to be 3 times 7. Oh, but look. So before I write them out, my giant 1 is here. So I don't want to put 3 here because I know 3 is not a factor of 28, so that won't work. So I'm going to swap them. I'm going to put 7. So I'm going to put 7 here times 3. So 7 times 3. And for 28, I know 7 goes here because they have to be the same in order for them to be a giant 1. And then I'll use my other factors, 2 times 2. Okay? All right, so 7 divided by 7 creates a 1. Any number divided into itself makes 1. And now let's multiply across. So 1 times 3 is 3. And I have 1 times 2 is 4. All right, so 21 28ths is equivalent to 3/4, and 3/4 is broken down into its simplest form. All right. Let me go ahead and pause the video.
Staff, please refer to your email.
All right, kiddos, sorry about that. But that was today's quick little morning announcement of red ribbon bracelets being passed out first period today. So we'll make sure we'll get those out. Okay. We are down to our last one. 9 and 33. All right, so 9. Very good. 3 times 3. Those are both prime, so we are done with our 9. 33. 3 times 11. Those are also both prime, so we are done there. Now let's use those prime numbers to simplify the fraction 9 over 33. All right, so let's take a look. If I'm trying to create a giant 1, for my 9, I'm going to put 3 times 3. For my 33, now what makes most sense to put in this giant 1? Yes, the 3, and then times 11. Okay, so I have my giant 1, 3 divided by 3. Makes a nice little giant 1. And now let's multiply across. So that's a 1, I know that, times 3 is 3. And this is also a 1 because it was a giant 1, and 1 times 11 is 11. All right, so 933 is equivalent to 9/11ths, but 9/11ths is special because it's the simplest form. So remember, that is the one that is broken down into its least amount of pieces. Okay, so quick recap of what we did today. So what we notice here is that giant 1s are used to simplify a fraction. So giant 1s have become important. They're not only to create equivalent fraction, but they also help us find the simplest form. So the version with the least amount of pieces, okay? And then we took a look at some giant 1 puzzles to simplify a fraction. And then here we worked side by side to see that, well, how do we get these numbers to simplify a fraction? Well, we prime factorize to find the factors for each number, and then we use the giant 1s to simplify the fraction. Okay? All right, kiddos. So that was your lesson on using giant 1s to simplify a fraction. This is hole punch for you, so this will not go into the notebook, but instead it will go into the math section of your binder. Okay. Now, if is any time left over, you may work on your weekly ALEKS topics. If there's no time left over, then I hope there was at least enough time to finish the notes. But it was a pleasure teaching you guys today, and have a wonderful day.